Hi, my name is Stefania Druga. I'm a PhD student at the University of Washington, and today I will tell you more about our paper, Family as a Third Space for AI Literacy. An entire generation of children are growing up with AI, with more than 47 million homes in US alone having a smart home assistant. Prior research has shown it is beneficial when parents get engaged in family learning of technology, helpful when children and parents engage together learning with new media, and that they're generally interested to learn about AI together and program smart games. What we still want to learn through our study is how children and parents learn about AI together and how we might design learning supports for family AI literacies. In our study design, we engage 15 families from more than 10 USA states that spoke more than 11 languages. These families participated in a 5 weeks in-home study, and they engage with 11 learning activities designed based on the theory of multiple literacies. The family's initial perceptions of AI showed that they are mostly considering these technologies to be useful. In addition, we noticed that parents and children's initial concerns would determine if and when they choose to engage with AI technologies at home. In our first session, we engaged parents and kids in learning more about image classifications. We had a playbook for families that explained how the learning activities would work and how image classification is being done. Then, participants played with a classification game where they got to sort 12 images of marine life into groups that they picked. They played with the anchor game where they got to pick segments of the marine life images in order to show what are the most important parts of the images. At the end of the session, we asked families to reflect on how a machine would play these games differently and how we could use the classified images to make something useful for society. Children primarily led the games in the image classification session. Parents acted as collaborators, mentors, mediators, and teachers. There were also instances of families with older children where the parents would learn from their children about the logic of image classification, and children would come up with scenarios for future use where they were considering involving scientists and experts in the process of crowdsourcing image classification games. Both parents and children recognized that a computer could make mistakes when classifying images because they are learning from people who can also make mistakes. In session 2, families learn about machine learning. They got to use mobile apps that allow them to detect in-home objects. They also played a scavenger hunt game where they trained a model to recognize different objects they have in the house. And at the end, they engaged with a prediction game where they had to guess what the machine would predict for very specific, tricky objects. In the machine learning session, both children and parents really enjoyed engaging in breaking, fixing, and training their AI models to recognize different objects. Parents suggested very different edge cases to their children in order to test the AI by picking different objects with similar shapes, by picking objects of the same color, or by just rotating the initial objects. In session 3, families got to learn more about voice assistants. They played an Ask AI game where they got to compare their answers with a voice assistant for specific questions and decide who answers better, the voice assistant or the family member. They also got to draw what is inside an assistant and how it works. Family members were much better at answering personal questions such as, do I have any pets? While the AI was much better at answering precise questions, such as reciting the first 10 digits of pi. Parents and children got to engage in reflection questions in deciding how much should a voice assistant know about their personal family history or family information. And both children and parents learned a lot about each other's assumption and understanding of AI by comparing each other's drawings. In the last session, in session 4, participants learn how to design and analyze AI. They engage in 3 different activities. They got to design their own smart assistants, they got to analyze existing home assistants they interacted with, and they got to play a bingo game where they were able to prompt and treat AI with different questions. Very important for children and parents to discuss what are the potential risks of having different sensors and different data being recorded by voice assistants. For example, one family suggested that they should make a voice assistant that does not record sound, but it actually works by detecting gestures, and it has a touch screen. Our qualitative results show that parents mediate children's learning by playing different roles, ranging from mentor to student. However, we observed a balanced partnership between children and parents, primarily when parents play the collaborator and tinkerer roles. While some of the roles we identify are similar to parent roles present in other family technology learning activities, the tinkerer and the student roles were unique to AI learning activities. When it comes to research question 2, we found that the embodied and tangible supports for learning were the most efficient because they supported the widest range of parental roles. In conclusion, we believe that AI literacy practices and skills led some families to consider making meaningful uses of AI devices they already have in their homes and redesign their interactions with them. These findings suggest that family has the potential to act as a third space for AI learning. We want to thank all the families who participated in our study and all our collaborators. The study materials are available online at aiplayground.me.